All right, notes look a little different this week. And the first thing I want you to do, we've got pages that are, top to bottom like normal, but this is like a sideways foldable. So I want you to go down, hit your pancakes and select 2-page view. And that way our pages will be side to side instead of, and unclick show cover page. That way they'll be side to side instead of top down. Okay. All right, so the last unit, we talked about, not inscribed, we talked about central angles. And what do we know about central angles? What are they? Okay, feels like a Monday. Okay, central angle is an angle that comes out of the center of a circle. So, for example, that's a central angle because its vertex is on the center. If the measure of this central angle is 100 degrees, what else do we know? Alyssa. Okay. Measure of this angle would be 260. How about the measure of the arcs? Measure of this arc would be 100 degrees, and the measure of this arc would be 260 degrees. The central angle has the same measure as the arc. Okay, so that's central angle. Today, we're going to add some things to that. Today, we're talking inscribed angles. All right, so Theorem 1 says if an angle is inscribed in a circle, actually, let's go back over here. I'm going to draw it to show you what an inscribed angle is. An inscribed angle is an angle that its vertex is on the circle instead of the vertex being at the center. So it looks more like this. Oh, come on. There. Anything where the angle vertex is at, it's actually around the outside of the circle. That's an inscribed angle. Inscribed means inside. So there's an angle inside the circle. Okay. So back to that Theorem 1. If an angle is inscribed, then the measure of the angle is half the measure of the intercepted arc. So here in example 1, we have an inscribed angle right there. the measure of the arc, BC, is 120 degrees. Find the value of x. Oh, okay. This is a little harder than I thought. Backing it up a step. The theorem says, inscribed angle. You don't have to draw this. If this angle is 40 degrees, then the arc angle is half of it. So it would be, the arc measure would be 20 degrees. Or am I wrong? Am I backwards? The angle is half the measure of the arc. No, I'm backwards. And I do it backwards every time. The arc measure would be 80 degrees. Okay. Let's show this over here. Here's the trick that I use to remember and double check myself. If I make an inscribed angle that opens up to a semicircle, kind of like that. So it opens up to a semicircle. So I know the measure of my arc is 180 degrees. And then I look at the measure of my angle. Is it 360 or is it 90? It's 90. Because I know it's either half or double. And I never remember which until I redraw it. Can't be double. Can't be a 360 degree angle. But it can half make sense. So this 90 degree angle, 90 degree angle opens up to a 180 degree arc. So the angle is the small one and the arc is the big one. So if I go back over here to this other example, if my angle was 40, then my arc is 80. If my angle is 35 degrees, what's the measure of the arc? 70 degrees. If the measure of the arc is 100 degrees, what's the measure of the angle? 50. Okay. Arc is double, angle is half. So back to the real example. They said the measure of arc BC is 120, but we are trying to find the value of x. Well, angle x is related to arc AB. Why 60 back there, Carson? Good. Not 160, 60. From A to C has to, oops, wrong button. From A to C needs to be 180 degrees because it's halfway around the circle because line AC is a diameter. So that means our 60 and our 120 had to add up to be 180. So the arc is 60. What's the angle? 30. Good. Arc is bigger than the angle. Okay. How about this one? This one's actually easier. Why didn't we do this one first? Just need a little algebra in here. Is our expression, are we going to set that, are we going to multiply by 2 or are we going to multiply it by a half? Alyssa. Yeah, we can do it that way. Double the angle. Because the angle was the small one, the arc was the big one. So if we double the angle, we'll get the arc. Or if you love fractions, you could multiply this half by 1/2. But I'm guessing most of us would rather just double the small one. So what's 86 times 2? 172? Distribute that 1/3, get rid of it. It's going to disappear. 1/3 times 9 is 3. 1/3 times 3 is 1. X is 57. Okay. Questions on those two? All right. So if you didn't do the drawing or over here in the theorem, you might want to just simplify the wording. In an inscribed angle, the angle is half the arc. If I could spell. Or you could say the arc is double the angle. All right. Simplify it for yourself. Okay, for theorem 2, we have two inscribed angles. We have two inscribed angles of a circle. Intercept congruent arcs, or the same arc. Okay, so I'm going to do it with one circle every time. Because if it works in one circle, then it's going to work in the congruent circle because they're the same. So what they're saying here is if you have an inscribed angle that opens up to this arc, let's call it arc AB. And you have another inscribed angle. Nope, I wanted to change the color. That opens up to the same arc, but it's over here, it's a different angle. Those two angles are going to be the same measure because they opened up to the same arc. Okay. Those two angles will be the same measure because they open to the same arc. Okay. So problem 3. Measure of arc ST is 72 degrees. Find the measure of angle 1 and the measure of angle 2. So just focus one at a time. Look at measure of angle 1. See how angle 1 is opening up to that 72 degree arc? So based on the previous theorem, it's half the size of the angle. Measure of angle 1 is 36. Then if we look at angle 2, the same thing is happening in a different spot. It's opening up to an arc that's 72 degrees. So the measure of angle 2 is 36 degrees. So we don't really need a special theorem to tell you that. You just inscribed angles opening up to the same arc. Makes sense that they're the same measure. Okay. Take a look at 4. Find the measure of angle 1 and angle 2. Sometimes there's a lot going on here. We've got angle 1 opens up to this arc. So that's the arc we're focusing on. Angle 2, it opens up to the exact same arc. So that tells you really don't need to find both angles. You just need to find one of them because they'll be the same because they open up to the same arc. But we don't know anything about the angle measures. We only know about arc measure right now. Let's see. Okay. This one is a little bit more of a thinker. I'm going to take that arc off. Forget about angle 1 and angle 2. Look at the arcs that we know. We know this 125 degree arc. Does it have a central or an inscribed angle that opens up to it? No, because its angle is like right there, and that's not the middle. So let's look at the 55-degree arc. Eraser. Does it have a central or an inscribed angle? Sure does. This angle right here opens up to that arc. So what's the measure of that angle? Not 25.2. 25.5. Right? Did I do that wrong? Thank you. 27.5. There's another angle that opens up to that 55-degree arc. So it's also going to be 27.5. Looks like I should change to a different pen. And then you're really going to start growing in here. So we currently have two angles that are the same, 27.5. We have these two angles are the same because they are, you may remember what those angles are called, the purple ones. Vertical, I think I heard somebody say it. Was it Carson? Vertical angles. And then we have these two segments that are marked as congruent. So these triangles are congruent. But does that help us get the measure of angle 1 and angle 2? This problem doesn't go with this theorem. We're going to leave. Go ahead, Ella.
Would the bottom of the circle be 125 too? There's a line.
It is, but we don't know that. We haven't learned that theorem yet. And maybe that's the problem is I didn't do the chord theorems. And maybe I should have done those first. That's a whole different lesson. So we'll go ahead and put it there. That arc, this arc here is going to be 125 from purple dot to purple dot. And there is a rule that explains that, but that's tomorrow's lesson, not today's lesson. So, oops. So if we know that, then this arc is easy over here. How do we find it? We got 360 minus all those other arcs. 360 minus 125 minus 125 minus 55. I got 55. Doesn't look like it, but hopefully I've instilled in you that drawings and geometry are generally bad drawings. So if that arc is 55, then what's the measure of angle 1? $27.5. Okay. Sorry, that was a little rough. Theorem 3. If an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle. This is kind of the same example that I gave you at the very beginning for how I remember if it's a 90 or not. If an angle hits a semicircle, then that angle has to be a right angle because it opens up to a 180-degree arc. And the arc is twice as big as the angle. So this theorem follows right after theorem 1. Oh, nice, easy question. What's the value of x? (180-degree arc). So x is 90. So in other words, if you have a triangle where one of the sides is the diameter, it's going to be a 90-degree triangle. Okay, find the value of x. So here, same thing. One of the sides of the triangle is the diameter. So this angle has to be a 90 because it opens up to a 180-degree arc. So then these two angles left over in the triangle have to add up to 90. Or if you want to do all three angles, then it's adding up to 180. 90 plus 2x plus 9 plus 4x minus 3 equals 180. All right, when you work out the algebra, you get 14. Okay, one more. Theorem. If a quadrilateral is inscribed, remember inscribed means inside a circle, then its opposite angles are supplementary. Okay. Again, this is totally based off of that first rule. Because let's look at the angle 70. It opens up to this blue arc. It means the blue arc would be 140. Okay. And if we look at the angle opposite of the 70, that would be the y. I don't want to copy anything. Go away. That would be the y. It opens up to the red arc. Well, the red arc has to be the other part of the 360. So that's 220. Which makes y 110. So the 70 and the 110 are supplements of each other, adding up to 180. Because if you double that, you get the whole circle. Because those two angles together create the whole circle. Does that make sense? Red angle open up to the red side. Blue angle open up to the blue side. So they have to be supplements because they have to add up to 360. Okay. Well, I got you your y. What's x? Ella.
125.
Yep. 180 minus 55. Okay. Number 8. I thought these last ones are easy and the first ones were hard. Value of x. So that one opens up to this arc. The other side opens up to the other side, other arc. Makes the whole circle. So if we were adding the arcs together, we'd set them equal to 360. But if we add the angles together, it's half of 360. Because the angle is half of the arc. Okay. So all 4 of these theorems are based off of that first one. That an intercepted angle, the angle has half the measure of the arc. or the arc is twice as big as the angle. So if you can remember that one, it will get you through all of those. Okay, so that's your main idea. I want you to link this into your CI notes, your circle notes. And then you have an assignment sitting in your Google Classroom, of course, because I don't ever let up. But it's also the assignment that you're working on tomorrow for the e-learning day. All right, so you have today and tomorrow to work on that. I actually would like to see it done Monday instead of waiting till the quiz, because I don't know how much we're going to pack into this quiz. So get it done for Monday. We'll talk about it then. By Monday, I'll have all those quizzes graded that you took yesterday. And then we'll go from there. I'm on it. All right, any other questions or concerns about
What are the notes called?
CI notes? Anybody at home have any questions? All right, Lana, if you refresh, you should be good.